So if we have a length of piano wire of a given density and we increase it by 5%, what approximate change in tension is necessary to keep the fundamental frequency unchanged? Well, these are one of these crazy ratio problems, but they're not too bad to work out, because we know how to work out ratio problems. So I'm just going to start off by writing down my original frequency. My frequency of the fundamental frequency is n over 2L square root of T over mu. Well, I know in this case this is going to be for the fundamental frequency, n is equal to 1. So F1 is equal to 1 over 2L square root of T over mu. Well, what I'm going to go to is I'm going to go to an F1 prime. This is where I increase the density of the wire by 5%, and I'm also going to change the tension in this. What I'm not going to change is L. I'm not going to change N. But this is going to be T prime over mu prime, a new linear mass density and a new tension. And I'm going to read the question again. It says that we're going to keep the fundamental frequency unchanged. So our final fundamental frequency is going to be equal to our initial fundamental frequency. All right, let's just start making some substitutions in. I will see that I can rewrite these two equations together, right? If this prime is equal to the unprimed. So that means 1 over 2L square root of T over mu is equal to 1 over 2L square root of T prime over mu prime. And I'll see that 1 over 2L cancel each other out. So I have T over mu primed square root is equal to T over mu. And I just start putting the mu or the primes on the wrong side. So yes, they flip, but it's the same equation. Well, if I square everything, nothing changes. I get, this says that I have T over mu is equal to T prime over mu prime. So if I increase mu by 0.5%, or by 5%, which is the same as saying original mu times 1.05, right? I increased it by 5%. To get T over mu, I need to have T increase by the same 1.05. So my T prime has to be an increase of 5% as well. If I increase the linear mass density, I have to increase the tension by the same amount to keep the same fundamental frequency. So it's kind of a fun little problem just to see how these pieces will work out. Some of these should have been kind of easy. Once I get our original equation, if I don't want f of n to change and I increase mu, I know I have to increase t as well. So decreasing are actually two answers that we probably could have instantly thrown out. How L changes with this square root in, I would be safe to work out the whole problem, but you could actually reason it out that says if mu increases by a certain amount, t has to increase by a certain amount as well because they're both under the square root.